Right, you're looking to cut through the noise and get a real understanding of AI in the USA quickly but thoroughly. Think of this as your direct route to the essential insights.
Yeah, the key developments, and really why America has become such a powerhouse in artificial intelligence.
Exactly. We've analyzed a detailed report called AI in USA, Future, Facts, and Frontlines, and this deep dive is all about pulling out the most vital information.
Mm-hmm. The turning points, the fundamental drivers behind the United States leadership in this, well, pretty revolutionary field.
So what's on our radar today? I mean, our source material gives us this panoramic view, right? It covers everything from defining AI and its American story.
Right, to the pivotal breakthroughs, the centers of research and talent, that crucial infrastructure
The
piece.
massive financial backing, big tech's influence, the policy side, which is huge.
And that ongoing discussion, open versus closed AI,
Mhm.
plus all the energy coming from startups and unicorns, it's a
It
lot.
really is a comprehensive picture.
And our goal here is pretty straightforward.
Yeah.
Synthesize all these different parts, highlight what's most
And
critical.
give you a clear, hopefully engaging understanding of why the USA is, well, leading the pack in AI right now.
Great, let's dive in. Core question first. What exactly is artificial intelligence?
Our source uses the term Banawadi Buddhamata, which, as it says, just means artificial intelligence. Fundamentally, it's about creating machines that can do tasks that usually need human smarts.
Yeah, we're talking systems that can learn, reason, solve problems, understand language, kind of like how we do.
And the way this actually shows up in the real world is fascinating. The source gives some great examples to make it, concrete.
Right, like take ChatGPT that's running on natural language processing, NLP, letting it chat with us.
Then there's Netflix.
Exactly, machine learning algorithms figuring out what you want to watch next, those recommendations.
Or Siri and Alexa using speech recognition to get what we're saying.
And Tesla's autopilot, that's a really complex mix of computer vision and decision-making working together.
It really is baked into so much now. Okay, so to get a better handle on it, the source breaks AI down into categories. First up, narrow AI or weak AI.
And the key thing here, as the source points out, is that this is what we mostly have today. AI that's really good at single specific tasks.
So back to those examples. ChatGPT does language, Google Maps does navigation, Alexa handles voice.
Facial recognition identifies faces. Each one is a specialist, basically.
Yeah,
Good at its one job.
got it. Then we move into something more theoretical, general AI, or AGI, artificial general intelligence.
Right. This is the idea of AI having human-level smarts across the board. Understanding, learning, applying knowledge to any task, just like a person.
Still mostly theory though, right? But people are working on it.
Oh, yeah. The source mentions figures like Elon Musk and Sam Altman actively pushing towards that AGI goal. It's the big prize for some.
And then there's a step beyond that, super AI, or artificial superintelligence.
This is where AI would actually surpass human intelligence in, well, pretty much every way imaginable.
Sounds a bit sci-fi. And potentially risky.
Well, yeah. Researchers like Nick Bostrom, mentioned in the source, raise serious points about the potential dangers if AI becomes vastly more intelligent than us. Control becomes a big question.
Okay, so narrow, general, super. But we're living firmly in the narrow AI world right now.
Exactly. That's crucial to remember. Now, let's unpack machine learning, or ML. The source calls it teaching machines through examples.
So it's a part of AI focused on training systems with data, letting them learn patterns instead of programming every single rule.
Precisely. You feed it data, and it learns. And there are different ways it learns. The source outlines three main types of ML.
Okay, what are they?
First is supervised learning. This uses labeled data. Think of an email spam filter.
Right, you showed examples. This is spam, this is not spam.
Exactly. And it learns to sort new emails based on those labels.
Makes sense. What's next?
Unsupervised learning. Here, the data is unlabeled. The machine has to find patterns or structures all by itself.
Like finding groups.
Yeah, a good example is customer segmentation. An algorithm might group customers by buying habits without you telling it which groups to look for beforehand.
Interesting. And the third type?
Reinforcement learning.
Yeah.
This is learning by trial and error, basically. An AI agent interacts with an environment, gets rewards for good actions, penalties for bad ones.
Like teaching an AI to play chess, it learns winning moves get rewarded.
Perfect example. Or
Yeah.
playing complex video games. It learns strategies through feedback rewards and punishments.
So supervised, unsupervised, and reinforcement, all ways machines learn from data. And the source connects this back to everyday stuff.
Right. Netflix recommendations, Amazon's people also bought, Google Photos recognizing your friends' faces, all ML working behind the scenes, learning from huge amounts of data.
It's kind of amazing how seamless it feels, even though there's complex ML underneath.
It really is pervasive. Okay, building on ML, we get to deep learning. The source calls it a significant evolution within machine learning.
Right. This uses neural networks, which are sort of inspired by the brain, lots of layers of algorithms learning together. Sounds complicated.
Kind of sophisticated, yeah, but the power comes from that depth. Multiple layers allow it to learn really complex, subtle patterns in data.
And examples here.
Think ChatGPT again, its language ability relies heavily on deep learning. The face unlock on your phone, the advanced perception in self-driving cars, all powered by deep learning.
So deep learning, more advanced ML, using these layered neural nets.
Got it. Now, language NLP, natural language processing. The source defines it as enabling machines to understand and process human language. Seems critical.
Absolutely fundamental for AI to interact with us naturally, text or voice. The source lists key uses we see constantly.
ChatGPT, Bard, Claude, obviously, Google Translate.
Grammarly helping with writing, those customer support chatbots we bump into online, all NLP.
It's gotten so much better recently, too. And that brings us to the really hot topic, generative AI. AI that creates new stuff. Exactly. This is where AI goes beyond just analyzing or predicting and actually generates original content.
Like text from GPT models.
Images from Delay or Midjourney, music from Suno.ai, even code from GitHub Copilot.
And now video, like OpenAI's Sora, which looks incredibly real.
Right. The source nails it by highlighting this combination of creativity plus automation. It's a powerful mix.
Feels like a whole new frontier opening up. Now, something the source really stresses is the role of data. The analogy, data is the new oil. That says a lot.
It's a perfect comparison. These AI models are hungry. They need massive amounts of data, billions of points sometimes, to train effectively. Images, text, audio, you know it.
And the source notes the U.S. has a big advantage here, both in data access and computing power.
Yeah, that's a key point. Having access to vast, diverse data sets and the infrastructure to process it is a major leg up.
And speaking of infrastructure, computing power is the other piece, especially GPUs, those graphics chips, mainly from NVIDIA, the engine of AI training.
Absolutely spot on. Training these huge, complex models takes incredible processing power. NVIDIA's GPUs, with their parallel processing, just became the standard for speeding that up.
Okay, so wrapping up Section A. We've covered AI basics, the different types, ML, deep learning, NLP, generative AI.
And the core ingredients: data, algorithms, and massive computing power. All areas where, as the source emphasizes, the USA currently holds a pretty strong hand.
Right. With that foundation set, let's move into Section B. How did the U.S. get this dominance in AI?
Exactly. The genesis story. How did the nation rise to the top and, well, stay there?
Okay, picture this. America in the 1950s. Cold War's heating up, tech competition is fierce, and a few scientists start talking about thinking machines.
Sounds like pure science fiction back then, right? But those early ideas, that initial spark, really laid the groundwork for the AI tools we use constantly today.
Yeah.
ChatGPT, Google Gemini,
And
Copilot.
the story of U.S. leadership isn't just tech breakthroughs, is it? The source highlights other factors.
No, it's way more than that. It's a mix of serious government funding, a particular kind of culture, and, importantly, national strategy. This section digs into how the U.S. built and kept that top spot.
So where's ground zero? The source points to the 1956 Dartmouth Conference. Sounds pivotal.
Oh, it was huge. Brought together the big names: John McCarthy, Marvin Minsky, Nathaniel Rochester, Claude Shannon. They didn't just coin the term artificial intelligence there.
What else?
They made this incredibly bold claim for the time, that machines could, in theory, simulate every aspect of learning and intelligence. Given they were working with transistors back then, that was pretty visionary.
Thinking machines must have felt miles away, but the research kicked off. The source talks about universities getting involved in the 60s, 70s, 80s.
Absolutely. Stanford became a major hub, especially after McCarthy moved there. LISP, that foundational AI programming language, invented at Stanford.
And MIT.
MIT's AI lab under Minsky was pushing boundaries in robotics and computer vision. Carnegie Mellon was big too, developing early expert systems like Dendrol and MyCIN systems based on rules.
So universities were the early incubators. And the U.S. government, DARPA gets mentioned, they were involved early.
Critically involved. DARPA Defense Advanced Research Projects Agency poured serious funding into early AI research. The government saw its strategic potential very early on.
Not just academic curiosity, then.
No way. They saw it as vital for military applications, national security. NASA, the DoD, they were interested too, providing support. AI was seen as a strategic asset right from the start.
But it wasn't all smooth sailing. The source mentions AI winters. Sounds chilly.
Yeah, there were a couple of rough patches, mid-70s to early 80s, then again late 80s to early 90s. Basically, funding dried up.
Boy.
The early hype didn't match reality. The algorithms just weren't delivering practical results yet, so companies and investors lost interest. Funding got slashed.
A major setback, surely. Did research just stop?
Not entirely.
Yeah.
And this is important. The source emphasizes the resilience of U.S. research during those winters. While the money got tight, crucial work continued in universities and national labs, quietly laying groundwork.
So the embers kept glowing. And then things picked up again. Late 90s, 2000s.
Definitely a resurgence. Several things happened. IBM's Deep Blue beating Kasparov at chess in '97 was huge, symbolically. Showed AI was getting powerful.
Right, that made headlines everywhere.
Plus, AI started finding real uses in healthcare, and the internet boom created vast amounts of data and new problems for AI to solve.
And Google's rise during this time was important.
Hugely important, according to the source. Google's work on PageRank, on NLP for search, it pushed AI forward significantly. The source calls Google an engine of AI revolution. Hard to argue with that.
Makes sense. Then comes the deep learning revolution, another massive shift, with the U.S. playing a key role again.
A total game changer. Now, the foundational ideas came from guys like Hinton, LeCun, Bengio.
But the source notes a lot of their key research happened in the U.S. or was funded here.
Exactly. The U.S. ecosystem supported that foundational work, and the breakthrough moment that really made deep learning explode.
What was it?
AlexNet winning the 2012 ImageNet Challenge. Its performance on image recognition was just stunning. That's when deep learning went mainstream.
And that boosted GPU use. NVIDIA.
Massively.
Yeah.
Suddenly, everyone realized GPUs were perfect for training these deep networks. NVIDIA was right there.
Okay, so deep learning takes off, and then U.S. big tech basically commercializes it on a massive scale.
That's the story. Google AI, buying DeepMind, developing TensorFlow, BERT, Gemini, they went all in.
Microsoft.
Huge partnership with OpenAI, integrating AI into Azure, creating GitHub Copilot, their Fair Lab, pushing open source Llama models,
Amazon.
Alexa, obviously, but also huge investment in AI through AWS machine learning services. They embedded it everywhere.
So these giants took the tech and ran with it. But the source also mentions something less tangible, Silicon Valley culture, a secret weapon.
It's a good way to put it. That whole ecosystem, innovation-friendly, okay with failure, plus the VCs like Y Combinator, A16Es, Sequoia, willing to fund big, risky ideas, it's fertile ground for AI.
A culture of try fast, fail fast.
Something like that. And it attracts talent. The source talks about brain drain elsewhere, but for the U.S., it's been brain gain.
Meaning top AI people come to the U.S.
Exactly. The best PhDs, researchers from India, China, Europe, they often see the U.S. as the place with the best funding, freedom, visibility. They migrate here.
A talent magnet.
Yeah.
And the military's role continued.
Oh, yeah. DARPA stayed heavily involved, autonomous drones, vision systems, predictive intelligence, Project Maven, working with companies like Anduril, Palantir.
And there's a national strategy, too, across presidents.
Right. Trump's 2019 executive order, Biden's 2023 order on AI safety and rights, bipartisan recognition of AI's importance.
So military and government strategy are intertwined with the tech development, and universities remain central. AI talent factories.
Absolutely.
Yeah.
Stanford, think Fei-Fei Li, Andrej Karpathy, MIT, CILIC Lab, Berkeley, Carnegie Mellon, NYU, churning out top research.
And publishing a lot.
Dominating, really.
Yeah.
Top conferences like NeuroPS, ICML, CVPR, platforms like ArtFeed, GitHub US researchers are everywhere.
So the academic pipeline is crucial. And one last point from this section, open source AI as a global gift from the U.S.
Yeah, this is significant. Think Hugging Face, based here with its Transformers library and model hub. OpenAI opening up access to models like Whisper, SealAIP, GPT APIs.
Making powerful tools available to everyone.
Pretty much. It democratizes AI development globally, which is a major contribution from the U.S. ecosystem.
Okay, so summing up Section B, U.S. AI leadership seems built on early investment, strong academia-industry links, that risk-taking VC culture, attracting global talent, military innovation synergy, a vibrant open-source scene, and even telling the story effectively.
Exactly. It wasn't an accident. It was and is a combination of all those factors working together over decades, a deliberate push.
All right, let's shift to Section C, landmark moments in U.S. AI history. It's clear the U.S. didn't just stumble into being an AI superpower. It was built on specific major achievements.
Right. These are the milestones, the breakthroughs that really showed what AI could do, captured public attention, and drove more investment and progress.
The source kicks off with a big one. IBM Deep Blue beating Garry Kasparov in chess, 1997. First time a machine beat a world champ.
And the significance wasn't just the tech, though that was impressive. It proved AI wasn't just a lab toy anymore. It could beat the best human minds at a complex strategic game.
The source calls it Cold War 2.0 on a chessboard. High-stakes symbolism.
Definitely. It put AI on the map globally. Then, fast forward to 2011. IBM Watson wins on Jeopardy! This felt different from chess, right? More about language.
Totally. Watson had to understand tricky questions, puns, context, then search vast amounts of info and buzz in fast. Against human champs.
Exactly. It showed a huge leap in natural language processing, deep search, context recognition, all in real time. It could handle the nuance of human language.
And the impact went beyond game shows.
Oh yeah. Watson demonstrated AI's potential for things like healthcare diagnostics, customer support, analyzing complex business data. It showed AI could understand information, not just calculate.
Okay, next big one. Google DeepMind's AlphaGo beating Lee Sedol in Go, 2016. DeepMind started in the UK, but owned by Alphabet Google, so it fits the US story. And Go is way more complex than chess.
Vastly more complex. Many more possible moves relies heavily on intuition, pattern recognition, not just brute force.
So how did AlphaGo win?
It used reinforcement learning and deep neural networks. Crucially, it learned largely by playing itself millions of times, developing strategies humans hadn't thought of.
Wow, so it showed AI could develop almost human-like intuition, strategic thinking without just copying human data.
Precisely. That's why it was such a big deal. It felt like a step towards more general intelligence.
A major leap. Okay, now we get to OpenAI and the GPT revolution, starting around 2015. This feels like when AI exploded into public consciousness.
Absolutely. OpenAI's founding, aiming for safe AGI, set the stage. Then the GPT milestones started rolling out.
GPT-2 in 2019, surprisingly good at writing text.
Yeah.
Made people think, wow, AI can write.
Yeah, it generated coherent paragraphs, which was a big step. Then GPT-3 in 2020, 175 billion parameters. That unleashed a wave of AI tools built on top of it.
And then the tipping point, ChatGPT launching in November 2022, it just went completely viral.
Its ease of use, its conversational ability, it put powerful AI in millions of hands overnight.
Yeah.
People suddenly got what large language models could do.
And they kept improving. GPT-4, GPT-4 Turbo.
Right. Adding multimodal capabilities, understanding images, better reasoning, longer memory. The GPT line basically took AI from the lab to our devices.
Incredible acceleration, and alongside this, tools like GitHub Copilot emerged around 2021, AI helping write code.
Yeah, that Microsoft OpenAI partnership, a huge boost for developer productivity. AI integrated right into the coding process.
And competition heated up, Anthropic's Claude series starting 2023.
Right, founded by ex-OpenAI folks focused on AI safety and reliability. Their Claude models improved rapidly, especially good with long documents, structured writing, became a major player quickly.
We also have to mention Meta's Llama models and their impact on open source.
Hugely significant. Meta AI releasing Llama, especially Llama 2, as open source, that really democratized things, gave startups, researchers access to powerful models they could build on.
Fueled a lot of innovation outside the big labs.
Definitely. And speaking of startups, the source notes an explosion of US-based AI startups from 2020 onwards. Riplet AI, Runway ML, 11 Labs, Character.ai.
VC money pouring in.
Billions. A real boom time for AI startups across the board.
And AI making inroads in creative fields, too. Runway, Midjourney, Sora.
Yeah. Transforming content creation.
Yeah.
Runway for video editing, text-to-video, Midjourney and DAL for images, and OpenAI Sora in 2024 generating those hyper-realistic videos from text. Another mind-blowing step.
Feels like the pace is just relentless.
Yeah.
Lastly, the source mentions government action again, executive orders, national AI strategy from 2019 to 2023.
Right. Trump's American AI initiative, then Biden's focus on safety, rights, risk mitigation, shows the government trying to keep pace, setting direction, addressing concerns.
So looking back at Section C, these milestones really chart the course. Deep Blue, Watson, AlphaGo, the GPT wave. The U.S. has consistently been where the big AI breakthroughs happen.
Absolutely. Leadership isn't static. It requires hitting these major milestones, and the U.S. has repeatedly delivered them, pushing the whole field forward.
Okay, let's move to Section D. The U.S. is a global AI research and talent hub. It almost feels obvious, right? Top AI scientists want to work in the U.S., major papers come from U.S. institutions, AI PhD students globally often aim for a U.S. visa.
That's pretty much the reality. The U.S. has built this environment that attracts, trains, and keeps top AI talent. It's the undisputed global center for AI R&D right now.
And the source points first to the top research universities. Stanford, MIT, Carnegie Mellon, Berkeley, the usual suspects, but powerhouses in AI.
They're not just teaching, they're defining the field. Stanford, right in Silicon Valley, with names like Fei-Fei Li, Andrew Ng, Key Labs. MIT's C. Ale, legendary for robotics, NLP, cognitive science.
Carnegie Mellon.
World leader in robotics, machine learning. Built early self-driving cars there.
Yeah.
UC Berkeley's Bear Lab, known for open source, applying AI practically. These places are the bedrock.
The foundation of U.S. AI talent. And this leads to dominance in research papers, journals, conferences.
Yeah, several reasons. Top AI conferences, NeurPS, ICML, CVPR, ACL, often hosted in the U.S. Huge funding from NSF, DARPA, NIH, plus private industry.
So more resources, more high-profile venues.
Exactly. And it shows in the output. The highest number of AML papers on ArcV, usually U.S.-based authors or co-authors.
It's a self-reinforcing cycle. And it's not just homegrown talent. The U.S. is a talent magnet, attracting brains from everywhere. The brain gain idea.
That's a huge factor.
Right.
If you're a top AI PhD student in India, China, Europe, the U.S. is often your #1 choice for grad school or postdoc.
Why? Better opportunities.
Better funding, more research freedom, higher visibility, connection to industry. Plus, visa programs like OPT and H-1B let international students stay and work after their PhDs, often getting snapped up by big tech or startups.
The source lists examples Andrej Karpathy, Ilya Sutskever, big names who moved to the U.S.
Exactly. It pulls in talent from all over the world. And beyond universities, there are national labs and research institutions playing a big role. DARPA, Allen Institute for AI.
What do they focus on?
DARPA pushes boundaries. AI safety, robotics, military AI, funding risky ideas. The Allen Institute, AI2, focuses on NLP, reasoning, knowledge graphs, builds semantic scholar. NASA uses AI for space robotics, imaging. National labs work on AI for climate, energy, defense. A whole ecosystem.
A diverse research landscape. And then there's big tech R&D, which the source says moves even faster than academia sometimes.
Often, yeah. Massive resources, clear goals, Google research, plus DeepMind pumping out models like BERT, PaulM, Gemini, top papers. Microsoft research strong in reinforcement learning, software engineering, AI ethics.
You're on a fair.
Llama, PyTorch, multimodal AI. Amazon AI Labs focuses on Alexa, computer vision, optimizing their operations. These places are innovation engines.
And they actively groom talent, fellowships, internships, hackathons.
Definitely. AI residency programs at Google Brain, OpenAI, Metafair offer deep research experience. Internships at Google, Microsoft, and NVIDIA are highly sought after. Top hackathons like MIT HackII, Stanford TreeHack Spot, and Nurture Talent, a whole pipeline.
A system for developing the next generation. And with all this power, ethical research is crucial. AI ethics labs.
Growing field. Places like Harvard's Berkman Klein Center, Stanford HAI, Human-Centered AI are digging into the societal impacts. Law schools at Yale, Columbia, Stanford are tackling bias, algorithmic justice, surveillance issues.
Essential work. And open source contributions again, providing tools for global talent.
Yes, this reinforces the hub status. TensorFlow from Google, PyTorch from Meta used globally. Hugging Face, US-based, is central with its Transformers library, model sharing, datasets. Free tools empower everyone.
Fosters global collaboration. And the source also mentions diversity inclusion efforts and global diplomacy.
Yeah, there's growing awareness about needing diverse perspectives. Scholarships, fellowships for underrepresented groups, women in ML, Black in AI, inclusive online courses from U.S. universities reach globally.
And on the world stage.
The U.S. leads many global conversations on AI safety, governance, military use, through things like the Partnership on AI, OECD AI principles. Joint research projects happen too.
So wrapping up Section D, it really is this confluence of Top talent, world-class training, cutting-edge tech, huge resources, and global connections that makes the USA the AI capital.
Exactly. The talent, the training, the tech, it all comes together here, creating this incredibly powerful research and development hub.
Okay, let's pivot to Section E, the USA's AI infrastructure backbone. We've talked about the brains in the labs, now let's talk about the body, the compute, chips, cloud infrastructure, largely driven by the US.
Excellent analogy. The best algorithms are useless without the muscle to run them, and the U.S. dominates the hardware and systems layer that makes large-scale AI possible.
First, name the source drops. NVIDIA, the king of AI compute. Started in gaming GPUs, now indispensable for AI.
Absolutely. California company, founded in '93. Their GPUs turned out to be perfect for the parallel processing needed in AI training. Their CDA platform accelerated everything.
And financially,
Exploded, became a multi-trillion-dollar company. Their chips are basically the standard for serious AI work right now.
so NVIDIA provides the core processing. Then the cloud tightens the infrastructure backbone. AWS, Azure, Google Cloud.
Right. They provide the massive scalable computing resources. AWS has the biggest U.S. cloud share, offers platforms like SageMaker, Bedrock.
Azure.
Microsoft Azure is OpenAI's exclusive cloud partner, running huge supercomputing clusters for GPT training.
Google Cloud.
They have their own custom AI hardware TPUs, tensor processing units, plus the Vertex AI platform. These clouds make AI development and deployment accessible at scale.
Digital powerhouses enabling the revolution. The source also mentions government-funded supercomputers like Frontier and Polaris.
Yeah, these are massive machines, often DOE projects, used for huge scientific AI tasks, drug discovery, climate modeling, fusion energy research, pushing the absolute limits of computation.
And it's not just general compute, there's a push for AI-specific chips, custom hardware.
Definitely. Google's TPUs were designed specifically for deep learning. Apple has its neural engine for on-device AI. Amazon built Inferentia and Trainium chips for cost-effective inference and training. Specialization is key for efficiency.
Makes sense. All this needs a physical home. The data center empire, these digital fortresses in the U.S.
The U.S. hosts a huge chunk, over 35% of the world's hyperscale data centers. Massive facilities needing tons of power, cooling, security, concentrated in certain areas.
The physical footprint of the digital world.
Exactly. And it's a whole industry itself. And related to that is the internet backbone U.S. strategic control. The U.S. has significant influence over core internet infrastructure, submarine cables, DNS routes, ICANN, and big tech companies lay their own high-speed fiber routes. A robust backbone is vital for moving all that AI data around.
Looking ahead, quantum computing R&D gets a mention. The next frontier for AI, IBM Quantum, Google Quantum AI.
Potential game changer for certain AI problems. Complex optimization, stuff classical computers struggle with. Still early days, but U.S. companies are leading the research push.
And the government is actively supporting infrastructure, the GPS and Science Act.
Big one. $52 billion to boost U.S. chip manufacturing, critical for hardware leadership. Also, the National AI Research Resource, NARAR, aims to give more researchers access to compute, tools, data. NIST frameworks provide standards, a coordinated push.
Seems like it. And open access platforms are helping democratize infrastructure too. Hugging Face, Mosaic ML, Stability AI.
Yeah, they make powerful tools and even compute more accessible, lowering the barrier for startups and researchers.
And there's a whole startup infra ecosystem. New chip makers like Cerebras, GPU cloud providers like Lambda Labs, CoreWeave, VCs funding this layer.
Absolutely. A whole ecosystem of startups tackling specific infra needs for AI, designing new chips, offering specialized cloud services. Lots of VC money flowing into this foundational layer too.
So putting it all together for Section E, the hardware, the networks, the data centers, the cloud platforms needed to actually do AI at scale, it's overwhelmingly based in the USA.
That's the bottom line. The U.S. has the physical and digital backbone to power the AI revolution, not just the ideas and talent.
All right, let's move to Section F, the trillion-dollar impact of AI investment and big tech in the USA. This isn't just science, it's a massive economic race, and U.S. big tech is clearly setting the pace.
Absolutely. The money involved is staggering, and how these giants are weaving AI into everything. They're basically shaping the digital DNA of the future. It's a trillion-dollar game they dominate.
The source starts with Microsoft as the OpenAI powerhouse. That $13 billion investment is just huge.
It's a defining partnership. Microsoft's Azure Cloud is the engine for GPT models, and now they're pushing Copilot tools everywhere. Word, Excel, Teams, GitHub, Microsoft 365, even security, embedding AI deep into workflows.
Right into how millions work daily. Then Google AI first since 2016. They've had so many breakthroughs.
Google DeepMind, Google Research, AlphaGo, AlphaFold, Gemini, Paul just massive contributions. Their Bard chatbot, now Gemini, TensorFlow framework, TPUs. AI is core to search, ads, YouTube, everywhere.
Hard to use Google without AI now. Amazon too, AI in everything, from cloud to cart.
Their reach is immense. AWS Bedrock and SageMaker provide the tools on the cloud side. AI drives their e-commerce recommendations, optimizes their logistics. Alexa keeps getting smarter with multimodal AI.
From shopping to smart homes to the cloud itself. Meta focused on AI for scale, open source, social intelligence.
Right. Their Fair Labs Llama models have been huge for open source. They use AI heavily to personalize Facebook, Instagram, Threads, research into vision language, embodied AI.
And Apple takes different path. On-device AI, privacy-centric.
Yeah, their strategy is more about processing AI tasks on the iPhone or Mac using their neural engine. Better privacy, keeps data local, powers things like image recognition, translation Siri, often without hitting the cloud. It's integrated, often subtle.
A different philosophy. Okay, beyond the giants, there's the VC ecosystem making billion-dollar bets on AI startups.
Huge driver. Firms like Andreessen Horowitz, A16Z, Sequoia, Lightspeed, pouring billions into the next generation. This fuels the AI unicorns, OpenAI, Anthropic, Scale AI, Runway ML, Inflection AI companies hitting that billion-dollar valuation shows massive investor confidence.
Fueling the fire at the startup level, and big tech also uses strategic acquisitions to grab talent and tech.
Standard playbook. Google buying DeepMind, partnering with Replit, Microsoft buying Nuance, GitHub, Amazon buying Zeus, self-driving, Apple buying Tori, Xnor.ai. It's a fast way to get cutting-edge tech and top teams on board.
A constant battle for talent and IP, and the source highlights the explosion of AI sauce tools coming out of the U.S. used globally.
Yeah, tons of tools for businesses and individuals. Enterprise stuff like Notion AI, Grammarly Go, Jasper.ai, Copy.ai. Creative tools like Runway ML, Descript, Pika Labs, U.S. innovation being sold worldwide.
Becoming essential tools for many. With all this power comes policy influence, big tech lobbying, participating in governance talks.
Inevitable, really. They're at the table for Senate hearings, AI risk summits, global groups like GPAI, OECD. They actively try to shape the rules of the game, understandably.
A complex dance between innovation and regulation. But the source acknowledges the potential downside of big tech dominance, centralization of power, closed models.
Definitely valid concerns. So much power over data, compute, research concentrated in a few hands. The closed nature of some top models raises questions about transparency, lock-in. It's a real tension.
Though the open source push and calls for regulation are responses to that.
Exactly. There's pushback and efforts to find balance. But concluding Section F, it's undeniable. U.S. big tech didn't just build AI, they scaled it, sold it, shaped it, making everyone globally pretty dependent on their platforms. Precisely. Their fingerprints are all over the AI landscape, making them central players in whatever comes next.
Okay, Section G, navigating the ethical landscape of U.S. AI. As AI gets more powerful, the questions of responsibility, safety, they become critical, right? It's not just what can we do, but what should we do?
Absolutely. Ethics can't be an afterthought anymore. It has to be part of the process.
Yep.
And the U.S. is, as the source shows, trying to build frameworks for policy and regulation.
The source details the White House's AI action plan, the blueprint for an AI Bill of Rights, the executive order on AI. Sounds significant.
Very significant. The Bill of Rights lays out principles. Safe systems, non-discrimination, data privacy, notice and explanation, human alternatives. The EI mandates safe AI use in federal agencies. Model reporting, red teaming, risk classification, government getting proactive.
Setting a tone from the top. And NIST, the National Institute of Standards and Technology, has frameworks too. The AI Risk Management Framework.
Right. The AI RMF 1.0 launched early 2023. It's guidance for organizations on building trustworthy AI governance, mapping risks, measuring impact, managing it continuously. A practical guide.
Building confidence and trust. And there are AI safety summits, global coordination efforts, Bletchley Park, the U.S. AI Safety Institute.
Yeah, recognizing AI is a global issue. The Bletchley Summit, UK, but US heavily involved, fostered shared understanding of risks from advanced AI. The new US AI Safety Institute will test models, develop safety benchmarks. International collaboration is key.
A multi-pronged safety approach. The source also mentions congressional hearings, tech CEO panels, leaders testifying before the Senate.
Vital platform. Policymakers grill tech leaders on risks, deepfakes, election meddling, IP issues. Bipartisan AI insight forums discuss potential laws. trying to get ahead of the problem.
Dialogue between tech and policy. And what about self-regulation? Industry commitments made to the White House.
In July 2023, OpenAI, Google, Meta, Amazon, Microsoft, Anthropic made voluntary promises, things like third-party red teaming, modern transparency, watermarking AI content. The Frontier Model Forum is another industry collaboration on safety R&D.
Industry trying to police itself to some extent, but major ethical challenges remain. Algorithmic bias, privacy breaches, legal responses like FTC investigations, CCPA.
Huge issues. Bias creeping in from data affecting hiring, facial recognition. It's a real problem. Privacy concerns with all that data being used. Laws like California's CCPA, FTC actions are trying to provide guardrails.
Complex problems. And AI's impact on labor laws, workforce disruption.
Big concerns there. Content writing, customer support. AI could displace jobs. Lawmakers are discussing transparency in AI hiring. Unions are demanding guidelines for AI co-workers. Needs careful thought.
Definitely. And the threat of deepfakes, elections, and misinformation seems particularly worrying right now.
Increasingly risky. Manipulated media targeting elections, spreading false narratives. It's a huge challenge for 2024 and beyond. Developing detection tools, watermarking, maybe laws against malicious deepfakes are all part of the response.
An ongoing arms race almost. AI in military and national security gets mentioned too. DARPA's work, but ethical concerns about autonomous weapons.
Right. DARPA works on AI decision aids, focusing on human in the loop. But the idea of lethal autonomous weapons raises profound ethical red flags. AI surveillance, too, needs strict controls.
High stakes indeed. Finally, the call for a global AI governance model. U.S. advocating for democratic governance, participating in OECD GPAI.
Yeah, the U.S. pushes for AI governance aligned with democratic values, contrasting with authoritarian models, proposing things like a UN AI Council, working through existing international bodies to set norms and principles globally.
Taking a lead role in shaping global rules. So, concluding Section G, it seems the U.S. is seriously grappling with the ethics, trying to build guardrails for a safe, fair, inclusive AI future.
Absolutely. The push for accountability alongside development is strong. Trust, built on clear rules, is essential if AI is going to be a true partner for society. The U.S. seems committed to that challenge.
All right, Section H, the tug of war between open source and closed AI in the USA. This isn't just tech specs, is it? It feels like an ideological battle, too.
You nailed it. It's about accessibility, transparency, safety, innovation. Fundamental disagreements on how AI should be developed and shared. It's a core tension in the U.S. AI scene.
The source defines them clearly. Open source public code, weights, data, modify, improve allowed, closed source proprietary models, API access, no peeking inside. And it notes OpenAI's shift from open to clouds is kind of ironic.
Yeah, that's definitely fueled the debate. The source then lists the U.S. open source AI champions.
Like Meta with Llama 2 and 3, widely used now, right?
Hugely. Foundational for many researchers and companies. Mistral 2 French roots, but big U.S. presence support known for efficient open models.
And Hugging Face. Can't ignore them. The central hub.
Absolutely pivotal. Platform for sharing, evaluating, fine-tuning models, essential infrastructure for the open community, plus grassroots groups like Eleuther AI, Stability AI.
Okay, then the closed source titans, OpenAI with GPT-4, GPT-4o fully closed.
Right, API access only. Anthropic's Claude model, safety-focused but closed weights. Google DeepMind's Gemini ultra-proprietary internal safety layers. Microsoft integrates closed models via Azure.
So two distinct camps. The source lays out the pros and cons. Open means faster innovation, transparency, community. But maybe misuse risks.
Exactly. Closed offers more safety control, stability, enterprise readiness. But risks, monopoly, lacks transparency, might limit outside innovation.
A trade-off, basically. And open source has had major impacts in the U.S., helping academia, startups.
Big time. Researchers can build on existing work easily. Startups get powerful foundations without huge API costs. Even enterprises use open models for specific tasks, keeping data in-house, or for edge AI with smaller models.
Empowering broader innovation. What about government support? The source says it's a mixed approach.
Seems that way. Encouraging voluntary safety standards for both. Proposing open infrastructure like NARAR. NIST guidelines aim to cover both. But defense might prefer closed for critical stuff, while using open for rapid prototyping. No single stance.
Safety and alignment is the biggest sticking point, isn't it? Misuse of open models.
That's the core debate. Can open models be made safe enough? How do you ensure alignment without central control? Closed models have moderation, but you can't audit them externally. It's tough.
Solutions being explored, like open weights but controlled fine-tuning, red teaming.
Yeah, people are looking for middle grounds. better testing protocols. It's an active area of research and debate.
And the market share battle. Closed AI leading now, but open source growing fast.
OpenAI, Google, Anthropic dominate the high end, but open source adoption is surging across many sectors. The landscape is shifting.
And underlying this is a culture and philosophy clash. Open source decentralization versus closed source control safety focus.
Definitely. Open source values, transparency, community collaboration. Closed source often prioritizes safety engineering, commercial viability, managing legal risk, different worldviews.
What about the future? Hybrid models, policy focusing on risk, not just open-closed.
Hybrids seem likely open models with closed safety layers, maybe? Policy is moving towards risk-based classification, setting standards for safe deployment regardless of the model's openness.
So the path forward likely involves borrowing from both worlds, finding balance.
Seems necessary. Collaboration, leveraging the strengths of both open and closed approaches, that feels like the way to get powerful and responsible AI in the U.S.
Okay, last section, section 1. The rise of AI startups and unicorns in the USA. So much energy here beyond the tech giants. It's exciting.
It really is. This ecosystem is incredibly dynamic. These startups and unicorns are driving a ton of innovation, challenging the big guys, creating entirely new markets.
The source gives an overview: rapid growth since 2020, huge VC investment, over $50 billion in 2023 alone.
The numbers are staggering. Growth across all sorts of sectors. VCs like Sequoia and Andreessen Horowitz are pouring money in, betting big on the future.
And we see the results. Prominent AI unicorns. OpenAI, Anthropic, Stability AI, Cohere, Hugging Face, hitting that billion-dollar valuation.
These are the leaders, really pushing the envelope. OpenAI with GPT, Anthropic on safety, Stability AI democratizing generative AI, Cohere for enterprise NLP, Hugging Face is the community platform. Heavy hitters.
And below them, a wave of emerging startups in specific areas. Healthcare AI, enterprise SaaS, creative AI.
Exactly. Startups applying AI to diagnostics, Tempest, Path AI, creating synthetic data, Synthesis AI, building video tools, Runway ML, image apps, Lenza, writing aids, Jasper. Innovation everywhere.
And venture capital is key. Mega rounds for the big names, but also early stage focus from places like Y Combinator.
Crucial fuel. Big rounds show confidence in the leaders, but incubators nurture the brand new ideas. Diverse founders bringing fresh perspectives too.
All this leads to innovation and disruption. New products, challenging old companies, new business models.
Totally. Startups are increasing productivity, creating personalized experiences, shaking up legacy industries, building global businesses from the ground up, forcing everyone to adapt.
But it's not easy for them. Challenges like data privacy, competition with big tech for talent, scaling costs.
Definitely tough. Navigating regulations like IBPay, GDPR, competing with Google, Microsoft salaries for engineers. Paying for the massive compute needed to train models? It's a high-wire act.
A competitive arena. The source shares success stories and lessons. Collaboration, ethics, agility are key.
Yeah, looking at OpenAI's stability, Cohere. Strategic partnerships matter. Integrating ethics from the start is important. Being nimble and just relentless innovation seem to be common threads.
And future trends. AI automation, sustainability AI, AI for cybersecurity, multimodal AI startups.
Looks like it. More automation across industries. Using AI to tackle climate change, bolstering cyber defenses, and startups handling text, image, audio all together. That's a big growth area.
So, concluding section 1, these AI startups and unicorns are really the engines of the revolution, huh? Their innovation, the investment, their vision points to a future where tech, ethics, business all converge.
Absolutely. They are key drivers, ensuring the U.S. stays vibrant and innovative in the AI space. They're defining what's next.
Okay, let's take a breath and wrap this up. We've covered a lot in this deep dive into AI in the USA.
We really have. From the basic definitions and the history,
To the landmark breakthroughs, the research and talent hubs, that critical infrastructure.
the massive investments, big tech's role, the policy and ethical debates.
That open versus closed tension, and finally, the dynamic startup scene.
It paints a picture of U.S. leadership built on many pillars: research, talent, infrastructure, investment, policy, and that vibrant startup energy.
So here's a final thought for you to chew on, building on all this. Given the incredible speed of AI evolution in the U.S. that we've discussed, what do you think will be the single biggest societal shift we'll see in the next 5 years because of this tech?
Ooh, that's a big question. Lots of possibilities there. Definitely something to think about.
It really is. Well, thanks so much for joining me for this deep dive today.
My pleasure.
We hope you found this look at AI in the USA informative and engaging. Lots more to explore out there.
So that was our very first episode of the AI series, where we explored the topic, what is AI and how did the USA become a global leader in it? We hope you enjoyed it. If you'd like to stay connected with our AI journey, make sure to like, share, and subscribe to the Core Cortex podcast. Keep listening, keep learning.